students, welcome to Grow Up Online Choosers and welcome to class on how to calculate the number of sigma bonds and pi bonds in a given compound. These questions are very simple in nature, but most of the students do mistakes on these questions. That's why I would like to explain how to calculate the sigma bonds and pi bonds in a simple manner. Now let us calculate the number of sigma bonds and pi bonds in a given question, that is 37. Before going to solve this question, you have to remember some points. When there is two lines are present, that means we call this double bond. These two lines indicates the double bonds. In double bond, one sigma and one pi bond is present. Next point is that when you observe three lines are present between two elements, that means these three lines are called the triple bonds. In triple bond, we observe that one sigma and two pi bonds are present. In triple bond, one sigma and two pi bonds are present. You have to remember these points while solving the number of sigma and pi bonds. Here, double bond contains the one sigma and one pi bond. Here, triple bond contains the one sigma and two pi bonds. Now, let us jump into the given question. The enolic form of ethyl acetate as given below. First of all, you have to identify the which one is enolic form. The word itself represents that enolic, that means en plus alcohol. That means double bond plus OH is present. This type of bonds are called the enolic forms. Here double bond is present, but there is no presence of OH group. That's why this is not an enolic form. This is an enolic form. Why? Because double bond is present and OH group is also present. This form is called the enolic form. Now let us try to calculate the number of sigma bonds and pi bonds in a given compound. This is the given compound. You have to calculate the number of sigma bonds and pi bonds in the enolic form. This enolic form will also be written as in a structural formula. That is, firstly write this enolic form into the structural form. This is called the structural form of the given enolic form. By writing of any compound in the structural form, you can easily calculate the number of sigma bonds and pi bonds present in this molecule. Okay, now let us try to calculate the number of sigma bonds and pi bonds. Previously know that one line indicates the one sigma bond and two lines, that is double bond indicates one sigma, one pi bond. Three lines, that means a triple bond indicates one sigma and two pi bonds. Now let us try to calculate the number of sigma bonds and the pi bonds in the given compound. Now let us firstly calculate the number of sigma bonds. Here 1, 2, 3, 4, 5, 6. In double bond, one sigma bond is present. Its number is 7, 8, 9. In this also one double bond, presence of one sigma bond. Its number is 10, 11, 12, 13, 14, 15, 16, 17 and 18. Here we observe that OC2H5 is written as O bond CH2 bond CH3. This O bond CH2 bond CH3 is also written in this way. Okay, we conclude that the number of sigma bonds is equal to 18. Now let us try to calculate the pi bonds. Here double bond, one sigma bond and one pi bond is present. Here one pi bond is present. Here another double bond is present. In double bond, one sigma and one pi bond is present. Here is the second pi bond. So the total number of pi bonds in a given compound is 2 and the number of sigma bonds are 18. Now let us verify the given options. Here option 4 satisfies our condition, that is 18 sigma bonds and 2 pi bonds. So our answer is 4 is our correct answer. Firstly, write the given compound in a structure formula. That means you have to write the structure in this way. You can easily calculate the number of sigma bonds and pi bonds. Now let us discuss the another question, that is 46. The number of sigma and pi bonds in the given int 2 in 4 is. Here we have to write the structure of this IUPAC name and then calculate the number of sigma bonds and pi bonds. Firstly, write the structure of this given IUPAC name. We know that firstly write the given how many carbons? Okay, here penta. That means 5 carbons are present. Here 1, 2, 3, 4, and 5. And next one is 2 in. That means at the second position there is presence of double bond. And the next one 4 in. That means at the fourth position there is a presence of triple bond. Now let us number these compounds here 1, 2, 3, 4, 5. Now let us satisfy the valency of carbon by adding of hydrogens. Here hydrogen, hydrogen, and hydrogen. Here are one hydrogen, hydrogen. Now let us try to calculate the number of sigma bonds and pi bonds in the given compound. Firstly, calculate the number of sigma bonds. Here 1, 2, 3, 4, and 5. We know that in double bond, one sigma bond is present. Here 6, 7, 8. We know that in triple bond, one sigma bond is present. Its number is 9, and last one is 10. So we conclude that in the given compound, 10 sigma bonds are present. Now let us calculate the number of pi bonds. Here, double bond is present. In double bond, one pi bond is also present. Its number is one pi bond is present in one double bond. Here, triple bond is present. In triple bond, we know that two pi bonds are present. So total 1 plus 2, 3 pi bonds are present in the given molecule. Now let us verify the given options. Here 10 sigma bonds and 3 pi bonds. So our answer is 1 is our correct answer. Here some trick is used to answer this type of questions. The trick is that when the given question asks to calculate the number of sigma bonds and pi bonds, firstly calculate the number of pi bonds. So you can easily eliminate the given options. There is no need to calculate the number of sigma bonds present in the given compounds when you calculate the number of pi bonds in the given compounds. When compared to sigma bonds, pi bonds, you can easily calculate in the given compounds. That's why firstly calculate the number of pi bonds, then you can easily eliminate the given options. This is the small trick to answer this type of questions. Now let us see the next example. Here they ask that the total number of pi bond electrons in the following structure is. Okay. Here they are asking the number of pi bond electrons. Here they are not asking about the number of pi bonds present in the given compound. They are asking the number of electrons present in the pi bond. Firstly, verify the number of pi bonds present in the given compounds. Here, 1, 2, 3, and 4. The pi bonds are present in the given compound. But they ask that the total number of pi bond electrons. We know that one pi bond contains 2 electrons. So here given compound contains 4 pi bonds. So the number of electrons will be 8 electrons. So our answer is 8 is our correct answer. Thanks for watching. I hope this content is useful for you. Please like the video and share with your friends and family members. Please comment if you have any doubt in the above content. Please do subscribe for more videos and updates. Thank you and all the best.